Hey there, ladies and gents. For this lesson, we are going to be talking about coterminal angles. Specifically, though, for today, we're going to be talking about coterminal angles with regard to radians. Now, coterminal angles are two angles that would land in the same quadrant. So, for instance, if I draw a coordinate system here, and I say that that is a 120-degree angle, you could argue that that's the same as going backwards negative 240 degrees. So previously, when we handled these, we just added or subtracted 360 degrees because that represents a full rotation around the circle. Well, same thing is going to happen for radians. However, for radians, instead of 360 degrees, we're going to be dealing with 2 pi radians. We can add or subtract 2 pi radians to any angle in radians. So, if I wanted to find a positive and negative coterminal angle for pi over 4, I could add or subtract 2 pi. So if I added pi over 4 plus 2 pi, well, hopefully we know that we would have to have common denominators. So this is a 1 pi over 4. Instead of 2 pi, I'm going to think of that as being 8 pi over 4. That still reduces down to the same thing, but now they have the same denominators. Right? So I just multiplied top and bottom by 4 essentially. So 1 pi plus 8 pi gives me 9 pi over 4. Using that same line of logic, if I pretended that that was a subtraction sign, and I'd had 1 pi minus 7 or minus 8 pi, I'd get negative 7 pi over 4. So there we would have a positive and a negative coterminal angle in radians for pi over 4. So, big thing to take away from this is anytime you want to find coterminal angles in radians, you simply add or subtract 2 pi. That's it, and that is all. All we are doing is adding or subtracting 2 pi. So let's go ahead and take a look at some examples here. By the way, if you need to pause the video at any point, please feel free to do so. Okay, so we want to find a positive and a negative coterminal angle to the given angles. These are all in radians. So we're going to be adding or subtracting 2 pi to each one of these. The only problem is my denominator is a 5. So instead of adding and subtracting 2 pi, I really need to pretend that I'm adding or subtracting something over 5. Well, 2 pi is the same as 10 pi over 5. So essentially I'm multiplying, if I think of this as a 2 pi over 1, I'm multiplying top and bottom by 5 so that the denominators match. I'm unsimplifying that fraction. So you're going to see with each of these, we're going to be adding and subtracting 10 pi over 5 to get our responses. So on each one, we're adding 10 pi over 5, adding 10 pi over 5. You can clearly tell that I was not the person who wrote this out. This was Miss Thestu, and her handwriting is just impeccable. So our final answers here, after we add or subtract 2 pi, or in this case 10 pi over 5, because we needed the common denominators, we would get 13 pi over 5 and negative 7 pi over 5 as our positive and our negative coterminal. Over here we'd have a 22 pi over 5 and a negative 8 pi over 5 as our positive and our negative coterminal angles. Now, as we get more and more used to our radian measures, we can start applying that to a unit circle. You guys can kind of see that, if this wasn't printed out on a black and white printer, these were color-coded. And if you want the color-coded format of these, it is available on the course schedule under the PDF of the notes. Anything that has a pi over 6, that's going to be one of my 30-degree reference angles. So whether it's 30, 150, 210, or 330 degrees. If it has a 6 underneath it, it will have a 30-degree reference angle. Easy way to remember that, 180 divided by 6. Holy smokes, don't say it, it's going to be 30. Same thing over here. Anytime we have a 4 in the denominator, that's going to be a reference angle of 45 degrees. It will be 45 degrees away from my x-axis. So 45 degrees away from the x-axis over here is 135. Down here would give me 225. And over here I'd have 315. Easy way to remember that, 180. If I were to divide that by 4, is going to give me, you guessed it, 45. 1/4 of 180 is 45 degrees. Using the same logic, we would get our 60-degree reference angle. Anytime I see a denominator of a 3, I will be 60 degrees away from the x-axis. So anytime we're dealing with something written in radians, ooh, what am I doing here? 300, not 30 degrees, yikes. It might be helpful to you to kind of visualize where that would be in terms of degrees. So later on, what we're going to get into is we are going to start seeing problems like this, where we are given an angle in radians, and we might need to think of that, well, what is that in degrees? That's 30 degrees. And just like before, we're going to find the sine and cosine of that angle. So pi over 6 was 30 degrees. Pi over 3, that's 60 degrees. Negative pi over 4, that's negative 45 degrees. So we can go through and figure out what is the sine, what is the cosine of all of these. Like I said, these notes are available for you online. Feel free to go through and copy all of this stuff down should you need it. The big takeaway, oh, there's the bell, is we're simply adding or subtracting 2 pi to get our coterminals, and cosine and sine still behave the same way from our unit circle.